So let's talk about polar graphs. This is going to be a lot more pre-cal review than it is going to be calculus, but we're going to build into the calculus, and we need to be familiar with what these graphs look like. So I'm going to spend a little bit of time in Desmos, a little bit of time in a TI, and then obviously I'm going to be doing some drawing as well. So the first thing I want to point out to you is that this is not an XY coordinate plane in the same way that you are used to. This is a polar plane. So when I think about that, this is like the unit circle. So this is the degree 0, this is the degree pi over 2, this is the degree pi, right? This is 3 pi over 2. So that's really important for you to understand. If I wanted to figure out what the radius is when cosine, we'll do theta here, r here, when the theta is 0, so at cosine of 0, what's the radius? Well, cosine of 0 is 1, so the radius must be 2. That point looks like this because it is at the 0 degree, 2 units out. Then I could also plug in a pi over 2. So pi over 2, I could do pi over 4 and such, but we kind of stick with the quadrantal angles a little bit. So if I do a pi over 2, well, now cosine of pi over 2 is just 0. So now I'm going to have 0, so that's kind of interesting. So I've got a point there. And then by the time I get to pi, remember pi is going to be out this direction to the left on the x-axis. So pi here, cosine of pi is -1, so I should be getting a -2. And the way that that works in a polar plane is instead of going this direction 2 units, because it's negative, you're going to go back this way. So I literally only have this point and this point to work with without doing any intermediary angles here. So what the heck does that graph look like? Well, I'm going to show you what it looks like in Desmos because I want you to see the way that it builds. So this is 2 cosine theta. So I have that, and I've got a little bit of a slider here so you can see it. So it starts off in that same 2, and then as the angle increases, it's going to go up and then come right back down to 0. So right there is about my pi over 2. And then here is from pi over 2 to pi. So that makes a circle. I've got a pretty good feel for what that is. So instead of me going, well, I don't know what's in between, I'm going to start recognizing this as a circle with a diameter of 2. So when I draw this, I'm going to be as careful as I can, trying to make sure that so a diameter of 2 units is going to be here and here. So there is my circle. So the reason why it's on the x-axis is because of this cosine theta. So that's important to recognize also. If I do 3 cosine theta, now I'm going to go out 3 units. So instead of me having to draw that in Desmos or try to build that in some way, I'm going to go, well, cosine of theta means I'm going to go out on the x-axis. Again, cosine of 0 is just 1, so I'm going to go out 3 units. And I know that that creates a circle. So again, this radius is basically 1.5 units. So I'm going to kind of go up to about there. I'm going to go down to about here. And there is your circle with a diameter of 3, but a radius of 1.5. So that's your cosine, right? So -3 cosine actually just goes to the negative side. So if I'm doing this, I'm going to go, again, plug in a point if that's what you need to do. Cosine of 0 is 1, but I'm going to go -3. So I was supposed to go this direction, but it's -3 units. So I've got to go that direction. Trying to get a few points to work with, and I do know the radius based on the diameter. So there's your -3 cosine of theta. I like to watch those circles build in Desmos. The way that the slider works, you can kind of see where it comes from and where it started. I think that's really important. So I am going to point out that the circle went all the way around, just 0 to pi. Okay, it's going to be really important that you pay attention to the domain on these. So one full revolution, one full circle is just 0 to pi. Because if we later on when we're doing area, if we go 0 to 2 pi, it's actually going to give me the area of 2 circles. So you've got to know this. Right, now, 2 sine theta. Again, I could build it. I could use this table. I could use this table of information and I could build a few, but I kind of have an idea of what this is going to do. So 2 sine theta is now on the y-axis, and now I'm going to go up or down 2 units. Same thing happens here, up or down 3 units. So I'm going to say, here's my 3, turn that one off. Here's my -3 sine theta. So let's show you kind of where that builds. Where does it start? Now this one starts at 0. Notice that the other one started, remind you guys, the other one started at the 2, but this one starts at 0. It goes down to -3 and then back up, but it's still 0 to pi. And it's the only reason why this is negative or in the negative quadrants is because of that -3. So when I go to build these, I'm going to go up 2 units. So there's my 2 sine theta. I'm going to go up 3 units. Again, my diameter is 3, which means my radius is about 1.5. Well, my radius is 1.5. But my points are a little bit off. All right, close enough. And then the -3, which I just built for you, is going to go down here into on the negative part of the y-axis. About right there, about right there. So there is our circle, or our circles. Now there's a couple of things to point out. So number one, I want to make sure you know that there's always symmetry with cosine. Cosine theta, let me be more clear. So cosine theta has symmetry about the x-axis. And then, of course, sine theta going to have symmetry about the y-axis. And we expect that based on our previous knowledge of sine and cosine. But that's going to be really, really important to us so we can build these more efficiently. And then pay attention to the negative. So be careful with negative coefficients. So, and do not forget this. You need to put stars by this. That domain is really going to matter. Circles are only going to be 0 to pi.